and proportion. So hope you have completed all the homework given to you. And once we are done through that, so today we are going to start with a new concept, that is a theorem on equal ratios. What it says, very interesting. It will help us to get the values of a given ratios, which seems to be like impossible for us. For example, if I will ask you x upon 7 is equal to y upon 3, with your current knowledge, you should be able to answer this. If you will be answering this, then there is no need of theorem on equal ratios. We can use our earlier knowledge and concepts to solve this type of a problem. But it seems to be a bit difficult if you go through this. If x by 7 is equal to y by 3, these are two ratios, and they're asking us to find the value of 3x plus 5y. What do you feel? How to solve this? Is there any other alternative, or what you can do? If you're going to multiply 3 to x, then we have to multiply 3 to 7. As per requirement, we require 5 with y, then multiplying 5 to y and 5 into 3. Yeah, okay. But how this plus will come into existence, since we are having two different ratios? We have seen this type of a ratio, that a by b is equal to c by d, and whatever we are having in denominator can be added to numerator with the help of componendo operation, that is a plus b upon b is equal to c plus d upon d. Okay, so okay, no problem. So because of this only, we need to study what is this theorem on equal ratios. Hope you understood why we are introducing this. Because of, we have to deal with this type of a problem. So let's start with the concept. So we know that if we are having two equal ratios, that is a by b is equal to c by d. So by theorem on equal ratios, what it says, it says that if we are having two equal ratios, then this ratio will be equal to adding the two numerators divided by adding the two denominators of the equal ratios. It remains same. And not only addition, but even though if you're going to use subtraction, then that would be the same. A minus c upon b minus d, as per requirement, what your question is demanding to you. So let's see how this is equal. Suppose if we are taking this ratio, that is a by b is equal to k and c by d is equal to k. So from here we are saying a by b is equal to c by d is equal to k. Okay. Once we get the value of a plus c upon b plus d equal to k, means they all are equal. So let's start. A by b equal to k implies value of a is equal to bk. C by d equal to k implies c equal to dk. Hope you understood. I'm just taking this denominator on right hand side, which takes some form of multiplication. Okay. So now consider a plus c upon b plus d. So because we need to prove na this is equal to k. Once it is equal to k means they are equal. And similarly we can do it for subtraction. So value of a is bk plus value of c is dk divided by b plus d. So now we can see what is common in this. We can take k common. What remains? B plus d remains divided by b plus d. Cancel this b plus d, same term in numerator and denominator. What remains? This is equal to k. So from 1 and from 2, from 1 and 2, we conclude that the ratio is equal. If we add two numerators of the ratio which are equal, then adding the numerator of the equal ratios upon denominator of the equal ratios remains the same. There is no change. Similarly, you can do it for subtraction, that is by taking a minus c upon b minus d. You will get the same answer, that is equal to k. And from here we conclude. So in the problems, as per the need, as per the requirement, we will use the theorem on equal ratios. So after this, we will move to our practice set 4.4. Please make a note, everyone. In practice set 4.4, question number 3, third, fourth, and fifth is being omitted as per guidelines of State Board. So please give a small cross to question number third problem, fourth problem, and fifth problem. So let's solve the practice set 4.4. We'll start. What is given? Fill in the blanks of the following. Fill in the blanks of the following. So we can see, as I've given you the example that it was difficult to solve with our earlier concept. Now we know theorem on equal ratios, so things become easy for us to solve the problem or go through the problem of this type, which we are going to deal with now. Question number 1, first part. Given x by 7 is equal to y by 3 is equal to 3x plus 5y upon, this is our blanks, is equal to 7x minus 9y, our blanks. So we need to get the value of this. 3x plus 5y divided by blank. So as per requirement, so therefore x by 7 is equal to 3 into x upon 21, and this ratio, as we are multiplying 3 in numerator as well as in denominator. So if you want, you can directly write 3x upon 3 into 7, but it's okay how you got this. I'm writing those terms, and we're having y by 3. So requirement says we require 5y. So multiplying 5 in numerator and denominator, what do we get? 5 3s are 15. So we got this. So this implies, so therefore 3x upon 21 is equal to 5y upon 15. Why this is equal? Because x by 7 and y by 3, they are equal ratios. So there are multiple with non-zero k, ratio remains same. The properties that we have done in our first lecture. 3x upon 21 is equal to 5y by 15, and this is equal to, as per requirement, 3x plus 5y divided by 21 plus 15. Reason by theorem on equal ratios. Now we can see that 21 plus 15 is 36. So 3x plus 5y upon 36. We have filled first blank. Now we'll move to next. As the requirement says, we require 7x, means x should be multiplied to 7 in order to get 7x, and we require 9y, we should be multiplying 9 to y. So therefore, second part, x by 7 is equal to, requirement is of 7x, so 7x upon, you can write here 7 into 7, no problem. So 7x upon 7 into 7 is 49. Next is y upon 3. Requirement says we require 9y. So 9 into y upon 9 into 3 is equal to 9y upon 27. So we got 7x upon 49 and 9y upon 27. So by using again theorem on equal ratios, therefore 7x upon 49 is equal to 9y upon 27. Why they are equal suddenly? Since it is given that x by 7 is same as y by 3, and using the property of ratio and proportion, 7x upon 49 is equal to 9y upon 27 is equal to 7x minus 9y upon 49 minus 27. Reason by theorem on equal ratios. By theorem on equal ratios. So answer is 7x minus 9y. Hope you got the answer for this. Yes, 49 minus 27 is 22. This is my second blanks. Done. So we have completed question number 1 first. Second is homework for you. As per requirement, what do you need to do in that? We are having a by 3, b by 4, c by 7. So in the first blanks, we require 2b. So multiply 2 to b and 2 to 4. So 2b upon 8. And we require 3c. So 3 to c into 3 into 7, that is 21. And as per requirement, by using theorem on equal ratios, you can do a minus 2b plus 3c and all that, dot, 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 dot. So you can try it by yourself. Homework to you. We'll move to next problem. That is question number 2. In question number 2, what they have given? 5m minus n is equal to 3m plus 4. So in this case, they have not given us a ratio. We need to find the ratio first, and after that we need to move accordingly as per their demand. as they have demanded find the value of m square plus n square upon m square minus n square, and after that 3m plus 4n upon 3m minus 4n. It's simple actually, but still we need to solve this, as this is a bit different from other problems in a given practice set. Question number 2, given 5m minus n is equal to 3m plus 4n. Now, what we need to do? We need to take the terms of m together and terms of n together. So 5m taking 3m to left hand side becomes negative is equal to taking minus n to right hand side becomes positive, as it was negative earlier. So 5m minus 3m is equal to, yes, answer from your side, huh? 2m is equal to 4n plus n is equal to 5n. So we got the ratio as m by n, means taking n to left hand side takes the form of division, and 5 divided by 2. So I got the ratio m by n as 5 by 2. Now what we need to do, as per their demand, we need to find first m square plus n square upon m square minus n square. So first we need to find the value of m square and n square. So m square upon n square means squaring both sides. What do we get? 5 square of 5 and 2 square. So 5 square is 25 upon 2 square is 4. So we got m square upon n square as 25 by 4. Now, set first part they are saying find the value of m square plus n square. As we have done in our last session, componendo and dividendo, as per the condition we can see. M square minus n square. This is question mark. So we can write here, therefore by componendo and dividendo, we get m square. Hope it is not visible. Let it be. I will be writing on the top. So by componendo and dividendo, and we are applying this on m square upon n square to get the answer. So m square plus n square upon m square minus n square is equal to 25 plus 4 upon 25 minus 4. So what do you get? Just add it. Here, students, answer from your side. Expecting. This all are basic calculation. You should be good in this. 25 plus 4 is 29. Divided by 25 minus 4 is 21. So answer of m square plus n square upon m square minus n square. Now we'll move to second part. What is the demand? They're asking us to find the value of 3m plus 4n divided by 3m minus 4n. This is the requirement. We'll be using m by n. Value of m by n is 5 by 2. From here we can see. We know that, or we have m by n as 5 by 2. So the demand is that with along with yum we should have 3, and along with n we should have 4. So therefore, multiplying 3 to yum and 4 to n, same thing we need to do on right hand side, that is 3 into 5 upon 4 into 2. What do you get? 3 into 5 is 15 divided by 4 to the 8. We got this. Now, as per requirement, as we can see, positive in numerator and negative in denominator, we need to go for componendo and dividendo again. So therefore, by componendo and dividendo, we get 3m plus 4n upon 3m minus 4n. Same we need to do it or apply it on right hand side. So 15 plus 8 upon 15 minus 8. Yes, answer. Anyone? Yeah. 15 plus 8 is 23. Divided by 15 minus 8 is 7. So our answer is 23 by 7. We are through. So we have completed question number 2 as well. And question number 3, total problem earlier was 5, out of which 3 is being omitted. That is third, fourth, and fifth. What remains? We are remained with 2 problems. So I should give one homework to you and one I will be solving. If time permits, I will be solving both for you. Okay. I will be solving both for you, no problem. Question number 3 first. We need to apply the concept of theorem on equal ratios as with or logic and understanding, and what is the requirement and what is to be done. Not just blind calculation is required. We should see where and how it is to be applied so that we will reach to our conclusion. Now, what they have given us question number 3 first. We have a into y plus z is equal to b into z plus x is equal to c into x plus y, with the condition that not two of them are equal. Means neither a is equal to b, nor b is equal to c, nor a is equal to c. Okay. Then we need to show that what we need to show, y minus z upon a into b minus c is equal to z minus x upon b into c minus a is equal to x minus y divided by c into a minus b. So as we can see, a, b and c in the given part, a, b and c, they are along with x, y and z. So, and as per the requirement, we can see that we require a, b, c in denominator. Since once the number is non-negative, means non-zero, we can divide any given term with that number. Example, if a is not equal to 0, then if we are having any number x and we need to divide it by a, yeah, we can divide it since it is non-zero. Once a is 0, we can't do this. So because of this only the condition is given that A is not equal to B is not equal to C, so that you can use the division as per requirement. So you can see that if we will divide the given part with A, B, C, what we will get? Let's see. I'll be solving it for you. So this is say given part is my equation number 1, dividing equation 1 by ABC throughout, since non-zero, ABC which is non-zero throughout. We get, what do we get? Let's take the given part. A into y plus z divided by ABC is equal to B into z plus x divided by ABC and is equal to C into x plus y divided by ABC. What we can see, we can cancel this A since ABC is non-zero. We can do this. What remains? Y plus z upon BC is equal to z plus x upon AC is equal to x plus y upon AB. Hope this is okay. Now, since you got this term, we have to use it carefully and logically so that this should not create a mess as per requirement. We require y minus z. We require y minus z. When do we will get y minus z? How do we get y minus z from here? If they're having the same term x in common, we can see y plus x plus z. This will be giving me y minus z. So before starting, let this whole ratio be equal to k, so that further we are going to solve it. So it should not change the meaning. So by theorem on equal ratios, now here we need to apply theorem on equal ratios. If I wouldn't be having this concept of theorem on equal ratios, then it was a difficult part to prove it. So by theorem on equal ratios, yes, how do we take a help of this theorem on equal ratios? In the way that will help me to reach the conclusion. See the way to reach that. So as we are taking theorem on equal ratios, it will not affect the adding and subtraction of two equal ratios as we have seen earlier. So just take a help of, as I have told you, the requirement is of y minus z. So y should be positive. So take this x plus y, x plus y. Requirement is of subtraction. So z plus x divided by AB minus AC. Hope you have understood it. I'm taking help of these two ratios, two equal ratios. And after opening a bracket, what I will be getting? X plus y, open the bracket, minus z minus x, terms with opposite sign gets cancelled. And what is common? A is common. What remains? B minus C. So here, what we got at last? Y minus z upon A into B minus C. As we have used equation number 1, so let this be my equation number 2. Next part, K is equal to. Next requirement is of Z minus X. Z minus X. So when do we will get Z minus X? If we are going to have y in common. Y in common. So we can use this too. So right, y plus z. This is also by theorem on equal ratios. The three ratios we're going to take, and that all three will be with the help of theorem on equal ratios. Y plus z minus y plus z minus x plus y. Since they are having y common, will be getting z minus x. Since z should be positive, so I've taken y plus z before x plus y, bc minus bc minus ab. So after opening a bracket, what we will be getting? Y plus z minus x minus y upon b common. So what remains? C minus a. Terms with opposite sign gets cancelled. So y gets cancelled. What remains? Z minus x upon b into c minus a. This is equation number 3. Similarly, we'll move to next ratio. So k equal to, now see again the requirement, we require x minus y. So how do we get x minus y? If we take help of z plus x and the first ratio, that is y plus z. So z plus x, since x is positive, so we need to take x before, minus y plus z and ac minus bc. So solve them. So after opening a bracket, z plus x minus y minus z upon c is common, take it outside, a minus b. Z gets cancelled. What remains? X minus y upon c into a minus b. This is equation number 4. So from 2, 3, and 4, what we have concluded, all are equal to k, means of the same ratio. So we conclude that y minus z, the requirement, what we need to prove, y minus z upon a into b minus c is equal to z minus x divided by b into c minus a is equal to x minus y upon c into a minus b. Hence done. Oh, one of the easiest problems. Only thing that we need to work on it properly. So if we know how to apply and what is the requirement, even though if we know what is the theorem and we don't know how to apply it, so we will reach to the wrong end, which is not good, which is not a good sign. So let's move to the second part of question number 3. What they're asking. Second, they have given us a ratio and they're asking us to show that this each ratio is nothing but equal to 1. So it's very one of the simplest problems. Just start with let k equal to whatever ratio they have given. They have given us x upon 3x minus y minus z is equal to y upon 3y minus z minus x is equal to z upon 3z minus x minus y. So we are having this ratios. So we have assumed it to be k. So and with the condition that x plus y plus z, this is not equal to 0. Not equal to 0 in the sense we are going to use it in denominator. Once something is non-zero means we can use as a division without any problem. If it is equal to 0 means we can't divide it. So by theorem on equal ratios, by theorem on equal ratios, k equal to, just add all of them, k equal to x plus y plus z, and here 3x minus y minus z plus 3y minus z minus x plus 3z minus x minus y. I have added the given all three ratios. Since the requirement is of condition x plus y plus z is not equal to 0, and we need to show that all the ratio is equal to 1. So we have added, and after adding, what we can see, what is our observation? Our observation is that x plus y plus z divided by, we can see 3x minus x minus x, matlab 3x minus 2x plus 3y minus y minus y, so minus 2y plus 3z minus z minus z minus 2z. Hope you understood this. X plus y plus z divided by x plus y plus z. 3x minus 2x is x, 3y minus 2y is y, 3z minus 2z is z. So we are having, now you can see observation. We are having x plus y plus z. This is not equal to 0, and hence we can divide it. So cancelling them, and we got each ratio equal to 1. So from this, from above, hence we concluded that, hence since we got y value of each ratio is equal to 1, since each ratio was equal to k, and we got k is equal to 1, we got k is equal to 1, hence the value of each ratio is 1. Hope this is okay for you. So now question number 4, last question of practice at 4.4. They have given us two problems which we need to solve it taking a help of theorem on equal ratios. So we can easily conclude the problem as we have done in the last lecture. There we have taken a help of componendo, dividendo, alternando. So here we need to take help of theorem on equal ratios. And I've told you that in order to divide by x or something, multiplying and dividing, that term should not be equal to 0. In last lecture also, and again we'll be seeing here also. Question number 4. First, given 16x square minus 20x plus 9 upon 8x square plus 12x plus 21 is equal to 4x minus 5 upon 2x plus 3. Now you can see we are having 16, 20, and here we are having 4, 5. But here we are having x square, and here we are having x. Also, if we will multiply with 4x, then what we will get? 16x square minus 20x, which is present here. As well as here it is 8x square plus 12x. If we will multiply with 4x in denominator, we'll be getting the same term, which is present here. So what we need to do? We need to multiply and divide by 4x. We need to multiply and divide by 4x. And once you are dividing by or trying to or you're thinking of dividing with x, first you need to prove that it is not equal to 0. And if it is not equal to 0 means it should not satisfy the given condition. So just replace x by 0 to check whether x is 0 or not. If it is not equal to 0, we can use the concept that I was talking about. But if once the condition satisfies, you can't use it. So 16 0 square minus 20 into 0 plus 9 divided by 8 into 0 square plus 12 into 0 plus 21. What we are doing? We are checking whether 0 is one of the solution for the given or value of x is 0 or not. If condition holds, then yeah, it is true. If not, then x is not equal to 0. We are just replacing here, put x equal to 0. So what we got? 9 by 21 is equal to minus 5 upon 3. Absurd case, not possible. So therefore, x, from here we conclude that x is not equal to 0. So we can do the step, whatever I've told you, that multiplying and dividing by 4x to the second ratio. So we can do it. Therefore, 16x square minus 20x plus 9 upon 8x square plus 12x plus 21 is equal to multiplying the second ratio with 4x. What do we get? 4x into 4x minus 5 divided by 4x into 2x plus 3. Reason, since x is not equal to 0. So as x is not equal to 0, we can use this step. Once x is 0, we can't divide it by 0. Make sure this. Uh, this is a concept which is very helpful to you. Once you don't know about this and you are dividing by x equal to 0, so it might go wrong and absurd case might arise. So therefore, what do we get? This is equal to 4 into 4 is 16, x into x square, 4 into 5 is 20. What remains? X divided by 4 2 is 8x square plus 4 3 is 12x. I got this. So now what we'll be doing? We'll be using by theorem on equal ratios. So just we'll write here by theorem on equal ratios. By theorem on equal ratios, requirement is that we should subtract, means we should take rid of the term so that we can get the value of x at last. So we'll be subtracting minus 16x square minus 20x divided by minus 8x square plus 12x is equal to 16x square minus 20x divided by 8x square plus 12x. Open the bracket. What do we get? Opening a bracket, we'll get 16x square minus 20x plus 9 minus 16x square minus minus plus 20x divided by 8x square plus 12x plus 21 minus 8x square minus 12x is equal to 16x square minus 20x divided by 8x square plus 12x. Terms with opposite sign in numerator and denominator gets cancelled. First, we will talk about numerator. 16x square minus 16x square minus 20x plus 20x gets cancelled. Here, minus 8x square minus 12x, 12x. So therefore, what remains? 9 upon 21 is equal to 16x square minus 20x upon 8x square plus 12x. What we can do is, since we are having x in common, so we can just take x common and cancel them and can proceed. Let's see how do we get that. So therefore 9 upon 21 is equal to, taking x common, so 16x minus 20 upon x common 8x plus 12. X gets cancelled, since you can write here, since x is not equal to 0. Therefore 9 into 8x plus 12, just taking a cross multiplication or taking the terms to left hand side and right hand side as per requirement. 21 into 16x minus 20. So from here, what do we get? This is nothing but easy calculation, what you can do it by yourself. So it's okay, no problem. 8 nines are 72, x plus 12 nines are 108 is equal to 21 into 16, that is 336x minus 21 into 20 is minus 420. So taking terms of x together and terms of taking terms of x together and constant term together, what do we get? 108 plus 420 is equal to 336x plus, sorry, minus 72x. So from here, we got 528 is equal to 336x minus 72x, 264x. So that is x is equal to 528 divided by 264. Ones are, twos are. So from here we conclude that value of x is equal to 2. Done. So the last problem is homework for you. This is being remained. You can apply the same concept and get through. First show that y is not equal to 0, then apply and you will get the answer. Hope you have understood. Thanks for watching, and in next lecture we'll complete the topic ratio and proportion. That is the concept of continued proportion. Yeah, thank you everyone. Almas ma'am. Almas ma'am. Hello ma'am. Hello. Hope you all have understood. Ratio and proportion is one of the easiest topics. Just keep on practicing. If you practice hard, things will become easier for you. And if you just listen the lecture and if you won't practice it, then you won't be able to understand each and every steps that we are doing here. Hello, ma'am. Hello, ma'am.
Yes, sir.
Hello.